Okay, you should have already had these written. Today we're going to be writing ratios. Today we are going to continue working with the writing of ratios and using ratio tables, okay? If I was to write the ratio for number 1, circles to triangles, somebody tell me what to write. What should I write, Braden? 6 to 8. Does everybody agree with that?
Yes.
Okay, I have 6 circles to every 8 triangles. Yes, sir.
You can simplify it to 3/4.
I could simplify down to 3/4. You're absolutely correct. Okay. Cashton, you want to do number 2?
Yeah.
Triangles to rectangles.
8 to 4.
8 to 4, and I can write it like this if I want to, can't I? Okay. What else can I do with that? How could I simplify it? What else could I do, Emmy?
2 to 1.
Say that again, babe.
2 to 1.
2 to 1. Thank you. So I have 2 rectangles to every, or 2 triangles to every 1 rectangle. What about rectangles to circles? Somebody tell me rectangles to circles. Ben,
4 to 6.
4 rectangles to 6 circles. What's the equivalent ratio with that? What's an equal ratio for that one? In other words, simplify it. What's it going to be, Jaden? 2/3 or 2 to 3. Good. Triangles to total number of figures. Is it going to get you here? Mr. Chance. 8 to 18. Can I write it like that if I want to? It's another way of writing ratios. Now, can that be written differently to simplify that out? Mr. Tyler.
4 to 9.
Tyler says I can simplify that 4 to 9. Writing ratios. Fist to 5. How do you feel just about writing the ratio? Fist to 5. Monique, I need your vote, honey. How do you feel about writing ratios? Fist to 5. Fist means I don't have a clue. 5 means I got this. I can rock it. I need a vote. I need to know where you're at. Okay? All right. When we're writing ratios, you take and you count up what it says, the number of circles that are there. And in this particular case, I have 1, 2, 3, 4, 5, 6 circles. Do you agree with that, Monique? Okay. How many triangles are there to those 6 circles? There's 1, 2, 3, 4, 5, 6, 7, 8. That's where the 6 to 8 comes from. Then, only thing we're doing there is we're simplifying. This one here is simplified. Okay? And the 2 are equal to each other. That's all they've done is they've simplified it. All right? How can you find 2 ratios that describe the same relationship? That's basically what I just talked about. How do we do it? How do we find 2 ratios that are going to describe the exact same relationship? We've been doing it. How do you do that? How do you do that, Roper? You simplify it. That's all there is to it. Okay? You're looking for equivalent, we call these Is it the same thing as this? Are equivalent ratios and equivalent fractions the same thing? They sure are. So if you can figure out if 2 fractions are equal, you can figure out if 2 ratios are equal. Yeah, I could possibly use simplify. That'd be one way. Okay. What would be another way? What would be another way? What if I told you you had to write, here's my ratio, and my ratio is, that's one of them. That's a ratio, 4 to 8. what is one equivalent ratio that goes with this? What is one? Jaslyn.
1/2.
Ooh, Jaslyn says 1/2. Do you all see where that come from?
Yes.
How did you get it there, Jaslyn?
I know 4 is half of 8.
So you simplified this one, right? I want you to write one more ratio that is equivalent to what we've got. We've got 4/8 and 1/2. What's another ratio that's equivalent to those? What's another one, Jaden?
2/4.
Jaden says 4/8, 1/2, and 2/4 are all equivalent. Do you agree with her?
Yes.
Jaden, how did you get 2/4?
I know half of 2 or half of 4 is 2 and half of 8 is 4.
So you simplified it in a different way. Okay? Esri,
Wouldn't 3/6 be equivalent to it as well?
okay, Esri. Is 3/6 equal to all these others? How do you know that? What did you do to get 3/6?
Because 3/6 is equivalent to 1/2, which is equivalent to 4/8.
She took the 1/2 and she said times 3. And she got 3/6. So 3/6 has to be equal to 4/8, 2/4. Those are all equivalent ratios. We simplified on some of them, but we multiplied on others. Okay? I can go either way. I can either simplify using division, or I can increase using multiplication. Either way. Either way works. Okay? This is how I do it. This is important. Okay? Very important. Yes, sir.
Okay, so 4/8 is 1/2, and 1/2 is 1/2, and 2/4 is 1/2, and 3/6 is 1/2. So wouldn't it just be keep going down like 2, 4, 6, 8, and then it repeats?
You could. I could say 5/10, couldn't I? I could say 20/40, couldn't I? Because I know that no matter what I say, it has to be equal to 1/2. That's the lowest form of it. Okay? All right, let's look at this one. Your partner is the whole class. A mixture calls for 1 cup of lemonade and 3 cups of iced tea. How many total cups does the mixture contain? How many total cups does this mixture contain, Cole? If I have 1 lemonade and 3 cups of iced tea, how many altogether do I have? 4 cups, good. For every blank cup of lemonade, there are blank cups of iced tea. Fill in the blank. Josie?
For every 1 cup of lemonade, there are 3 cups of iced tea.
Okay. So is this ratio 1 to 3?
Yes.
Okay? I got to see what before I say this, because the next slide may do what I want it to. I forget from time to time. All right. Now then, we're going to create a table using this information. Okay? We're going to create, because that's what our whole activity is about. How do we use tables when working with ratios? Okay? Work with the partner. A mixture calls for 1 cup of lemonade, 3 cups of iced tea. We started out with how many total, so we had 1 to 3, do we agree? For a total of 4. Okay? How many total cups are in your final mixture? How many of those cups? Okay. What if I got more people that come to my house. Everybody gets a cup. play with it a little bit. Okay? Can I make 5 cups of this mixture? That'd be kind of an awkward one, wouldn't it? I don't want to do that. You know why I don't want to do that? Because that would be uneven. Every recipe makes 4, right? So the next recipe, if I make it bigger, is going to make how much?
8,
And the next one would be
12.
oops. Oh, yeah. I'm gonna go right there. I'm gonna go really big. Got a big party. So for 8 cups, how much lemonade do I need? 2 cups of lemonade. How many cups, Monique, of iced tea do I need? If I have 2 cups of lemonade, how many cups of iced tea do I need? How'd I go from 1 to 2? Did I divide or multiply? Multiplied by what? By 2? Okay. So if I remember, a ratio can be written like a fraction. If I multiply the numerator by 2, what do I have to do to the denominator? Multiply it by 2. So if I have 2 cups of lemonade, how many cups of iced tea do I have? 6. Good job. Okay? Now I'm making it even bigger. So altogether, do I have 8 cups? Does it add up?
Yes.
Okay? If my parts are 1 to 3, if I have 3 cups of iced tea, or 3 cups of lemonade, how many cups of iced tea do I have, Chloe?
9.
Altogether, does that make 12 cups? You can check your math, right? Because these 2 had better add up to the bottom, shouldn't they? They got to. All right? If I've got 16 cups, I'm actually making that 4 times larger, aren't I? So I got 4 cups of lemonade. How many cups of iced tea do I have? How many cups of iced tea do I have? Josie?
12.
She says 12. 16 plus 4 is, or 12 plus 4 is 16, right? What if I know I have 5 cups of lemonade? How many cups of iced tea do I have? Esri? 15.
40's
40, he says, is hard to figure out.
hard.
Cadence, what do you think? Or, sorry, Kaylee. You saying 20 here? And if that's so, how many cups of iced tea would I have to have? But would that come back to here? Huh? Nope, can't be that then. Good try. What's it going to be, Braden?
Cups of lemonade is 10, and cups of iced tea is 30.
How do you know that?
Because 5 plus 15 equals 20. If you take 5 times 2 equals 10. 15 times 2 equals 30.
He went from here and multiplied it. Now, here's what I saw. I had this across the bottom, right? And I knew I wanted 40 cups. Well, look. If I had 20 cups here, I'm getting how much bigger to get 40 cups? 20 more, or how many times larger?
2 times.
2 times larger. 2 times 20 is 40. 2 times 15 is, 2 times 5 is,
10.
I also come back here. I started out with 4. 40 is how much larger than 4? 10 times larger. 10 times 3 is 30. 10 times 1 is 10. There's many different ways that you could come to that. But you have to look at the table and see what you know. And then apply it. This one takes a little, it's a deeper thought, okay? I don't know that you're going to see a lot of those, okay? Very likely, though, you may see one where there's bits and pieces of it that are missing and you have to fill in the blank. Okay? How many total cups are in our final mixture? How many total cups were in our final mixture? 40. Okay. How many of those cups are lemonade? 10. We don't have to compare. And how many are iced tea? 30. Okay. Just answering the questions. We don't have to compare though because we're all doing it together, right? Okay. Your assignment. We're going to look at something before I turn you loose. Because I have time. Math Journal 5.2. Page 102 in the journal. Oh, they're just not even. Wait a minute, that's not the right page number. I don't think. Hang on. 104, okay? I want you to do 104. Page number's wrong. We're going to look at number 1. We are going to look at number 1 as a group. You have a table that looks like this. And remember I told you your tables may have parts but not all pieces. And that's what you got. You got a piece that looks like this. And this is kids. And this is grown-ups or adults. And they put a 3 here and a 1 here and a 3 here. And you got to find the missing piece. You got to find the missing piece. So what's the missing piece in number 1? What is the missing piece, Ben?
6.
How do you know that, Ben?
Because, no, I think it's 5.
He says, oh, maybe it's 5.
5 or 6, I think.
How would you get there then, Ben, if that's what it is?
Because, like, on adults it would be 3 times 1 would be 3. So 3 times 2 is 6. Well, 9. 9.
So how many? What's my missing piece?
9?
9. And that right there, then it says, then write the equivalent ratio. So you had to put in the table, and then you have to write it. 3 to 1 is equal to 9 to 3. Now, if you're not sure where this 9 comes from, you ask yourself, how'd I get to there? Well, 1 times 3 is 3, so 3 times 3 is 9. Okay? Sometimes, Roper, it might be easier to write this ratio that you've been given as a fraction. And then write the other piece, leaving that blank and figuring out, well, how did I get from here to here? Okay? Sometimes if you look at it as a fraction, because they're the same thing, it makes more sense to you because you've been doing fractions. That's how you're going to do all of them. Do what? Yes, in number 5, you're going to have 3 ratios written because you have 3 ratios there. You have the one they give you and then the 2 that you create. Okay? Number 7 says you read 1 chapter every hour. You read for 3 hours after school. How many chapters did you read? You got to calculate that. Okay? And then you go to the textbook page 35 or page 203, 35 to 38. We did number 1 for you. You get to do the rest. Okay?